The year is 1942, and the United States has been fully engaged in World War II for less than a year, but the urgency of total mobilization has already transformed American industry and military procurement into the largest weapons production system in human history. Factories that once manufactured automobiles, refrigerators, and washing machines now turn out tanks, aircraft, and firearms at rates that astound both allies and enemies. In this environment of rapid development and desperate innovation, the boundaries between what is practical and what is merely possible become blurred. Engineers and ordnance officers explore every conceivable modification, combination, and adaptation that might provide American forces with tactical advantages. Among these experiments is one of the most ambitious and ultimately impractical attempts to enhance infantry firepower. The effort to mate the M1 Carbine, a lightweight, compact semi-automatic rifle designed as a pistol replacement for support troops, with the 50-round drum magazine from the Thompson submachine gun, creating a hybrid weapon that would theoretically combine rifle range and accuracy with submachine gun ammunition capacity. The M1 Carbine, formally adopted in 1941 and entering production in 1942, represents a completely new category of infantry weapon. It fires the .30 carbine cartridge, a round substantially more powerful than pistol cartridges, but significantly less powerful than full rifle cartridges, like the .30-06 Springfield. The carbine weighs approximately 5 pounds empty, half the weight of the M1 Garand rifle, and measures just over 3 feet in length. It is designed to arm personnel whose primary duties do not involve frontline infantry combat: officers, radio operators, truck drivers, artillery crews, tankers, and support troops who need something more effective than a pistol, but who cannot be burdened with a full-sized rifle. The standard magazine holds 15 rounds and feeds from below into the receiver through a conventional magazine well. The carbine operates via a short-stroke gas piston system that is reliable, simple, and requires minimal maintenance. Within months of its introduction, the M1 Carbine becomes one of the most produced American firearms of the war, with multiple manufacturers producing millions of units. The Thompson submachine gun, by contrast, has been in service since the 1920s and is already well established in American military and law enforcement arsenals by 1942. The Thompson fires the .45 ACP pistol cartridge from a blowback-operated action and is available with either stick magazines holding 20 or 30 rounds or drum magazines holding 50 or 100 rounds. The drums, particularly the 50-round drum, are mechanically complex devices using spring-driven rotary feeding mechanisms to advance cartridges from a circular housing into the weapon's feeding path. These drums are heavy, expensive to manufacture, somewhat unreliable under field conditions, and gradually being phased out in favor of simpler stick magazines by the time experimental work begins on mating Thompson drums to M1 carbines. But in 1942, the drums are still in production and still being issued, which makes them available for experimental use. The concept of fitting a Thompson drum to an M1 carbine likely originates from the same impulse that drives much wartime weapons experimentation: the desire to combine the best characteristics of different weapons into a single superior system. The M1 carbine offers lightweight, compact dimensions, semi-automatic fire, and rifle-like accuracy at ranges up to 200 or 300 yards. The Thompson drum offers high ammunition capacity that allows sustained fire without frequent reloading. If these characteristics could be combined, if the M1 carbine could somehow accept and reliably feed from a 50-round drum magazine, the resulting weapon might provide support troops with firepower approaching that of submachine guns while maintaining the range and accuracy advantages of the carbine. On paper, the concept has appeal. In practical implementation, the engineering challenges prove nearly insurmountable and the tactical value questionable. The fundamental obstacle is that the Thompson drum magazine and the M1 Carbine were designed for completely different cartridges with completely different dimensions. The Thompson fires the 30.5 ACP, a short, fat, rimless pistol cartridge measuring approximately 1.27 inches overall length, with a case diameter of about 0.476 inches at the base, tapering to 0.308 inches at the neck. The internal geometry of the Thompson drum, the spiral track that guides cartridges, the feed mechanism that positions them for chambering, the spring mechanism that provides feeding tension, is optimized specifically for the .45 ACP dimensions. Simply loading .30 carbine cartridges into a Thompson drum would result in complete feeding failure because the rounds are the wrong shape and size for the magazine's internal architecture. Creating a functional drum magazine for the .30 carbine cartridge based on Thompson principles requires essentially designing and building a completely new magazine that superficially resembles a Thompson drum but internally is configured entirely differently. Engineers must recalculate the spiral track geometry to accommodate the longer, narrower cartridge. They must redesign the spring mechanism to provide appropriate tension for the different cartridge weight and the different feed path length. They must modify or completely redesign the feed tower, the portion of the drum that interfaces with the weapon and presents cartridges for chambering, to position .30 carbine rounds at the correct angle and height for the M1 Carbine's feeding system. This is not adaptation. This is creating a new magazine from scratch while maintaining external dimensions and attachment methods compatible with some form of M1 Carbine receiver. The M1 Carbine itself requires extensive modification to accept any drum magazine. The standard carbine has a magazine well sized and shaped for the slim 15-round box magazine. This magazine well is part of the receiver casting and cannot be easily modified without compromising the structural integrity of the receiver. Adapting the carbine to accept a drum magazine likely requires one of several approaches: designing an adapter that fits into the existing magazine well and provides a mounting point for the drum, creating a completely new lower receiver designed from the start to accept drum magazines, or designing a drum magazine with a feed tower that somehow interfaces with the existing carbine magazine well, despite the geometric incompatibilities. Each approach presents unique engineering challenges and requires substantial development work. Assuming engineers overcome these mechanical challenges and create a functioning prototype, a modified M1 Carbine that can actually accept and feed from a 50-round drum magazine loaded with .30 carbine ammunition, the resulting weapon system faces a host of practical problems that become apparent during testing and evaluation. The weight issue is immediate and obvious. The standard M1 Carbine weighs approximately 5 pounds empty. A 50-round drum magazine for .30 carbine ammunition using construction methods similar to Thompson drums would weigh approximately 4 to 5 pounds when fully loaded, roughly the same weight as the entire carbine. Attaching this drum to the carbine creates a weapon system weighing 9 to 10 pounds, concentrated in a way that makes the weapon extremely unbalanced and awkward to handle. The Thompson drum, when attached to a Thompson submachine gun, mounts horizontally from the left side of the weapon or vertically from below, depending on the specific drum configuration. Either mounting position creates handling problems when adapted to the M1 Carbine. A side-mounted drum makes the weapon asymmetric and difficult to shoulder properly. A bottom-mounted drum extends several inches below the carbine, interfering with firing positions and making the weapon difficult to deploy from vehicles or carry through confined spaces. The weight distribution is problematic regardless of mounting position. The carbine was designed to be balanced and handy, and adding a multi-pound drum to any attachment point destroys that balance, creating a weapon that is nose-heavy, difficult to aim quickly, and tiring to hold in firing position. The bulk of a drum magazine creates interference problems that become apparent during field testing. Soldiers attempting to carry drum-equipped carbines discovered that the drum catches on vehicle doors, equipment straps, vegetation, and door frames. Going prone requires positioning the body to accommodate the drum rather than settling naturally into firing position. Transitioning quickly from movement to firing is slowed by the need to orient the weapon so the drum does not strike obstacles. These may seem like minor inconveniences, but in combat where every second matters and where fluid movement can mean the difference between survival and death, such interference problems are serious tactical liabilities. Loading a 50-round drum magazine is time-consuming and requires either a loading tool or significant hand strength and patience. The Thompson drums, which would serve as the design basis for any .30 carbine drum, require several minutes to load fully even with the proper loading tools. The process involves opening the drum, inserting cartridges in the spiral track in the correct sequence and orientation, closing the drum, and winding the spring mechanism to proper tension using a key. In the field, this loading process must be performed carefully to avoid damaging cartridges or the magazine mechanism. Rushing the process often results in improperly seated cartridges that cause feeding failures when the drum is used. The practical implication is that drum magazines must be loaded in advance during quiet periods and carried loaded until needed. They cannot be quickly reloaded during combat like box magazines can. The feeding reliability of drum magazines under field conditions is historically problematic across all weapon systems that employ them. The complexity of the rotary feeding mechanism, the numerous internal components that must work in precise coordination, and the sensitivity of the system to dirt, moisture, and mechanical wear all contribute to higher malfunction rates compared to simpler box magazines. The Thompson drum magazines are notorious for feeding failures when subjected to rough handling, dirt infiltration, or when the spring tension weakens from being left loaded for extended periods. A drum magazine designed for the .30 carbine cartridge would likely exhibit similar reliability issues, and possibly worse ones, given that the .30 carbine cartridge's bottleneck shape makes reliable feeding more challenging than with straight-walled pistol cartridges. The tactical question becomes central during evaluation of experimental drum-fed M1 carbines. What specific combat situation requires this weapon's particular combination of characteristics? The concept assumes that there are scenarios where 50 rounds of .30 carbine ammunition fired from a lightweight carbine provides capabilities that existing weapons cannot match. But examination of actual tactical employment reveals that this niche is either non-existent or already filled by other weapons. For close-quarters combat where ammunition capacity matters most, the Thompson submachine gun provides fully automatic fire with proven reliability and acceptable weight characteristics. It may be heavier than a carbine, but it is purpose-designed for the role and executes it effectively. For situations requiring rifle range and accuracy, the M1 Garand provides superior ballistic performance in a package that, while heavier than the carbine, is optimized for infantry combat. For support troops who need something between a pistol and a rifle, the standard M1 carbine with 15-round magazines, and soon with 30-round magazines as they become available, provides adequate firepower in a much more practical package. The experimental drum-fed M1 carbine occupies an uncomfortable middle ground where it combines disadvantages from multiple weapons categories without providing compensating advantages. advantages. It is heavier and bulkier than a standard carbine, negating the carbine's primary appeal as a lightweight secondary weapon. It lacks the full automatic capability of the Thompson, making it less effective than submachine guns in close combat, despite the increased capacity. It uses a less powerful cartridge than the Garand, limiting its effectiveness at rifle ranges, despite having carbine-like dimensions. The 50-round capacity sounds impressive until one considers that it comes at the cost of weight, bulk, complexity, and reliability issues that the soldier must accept in exchange for ammunition capacity that may never be needed. The ordnance testing and evaluation process involves building small numbers of prototype weapons and subjecting them to range firing, reliability testing, and simulated tactical employment. Engineers gather data on feeding reliability, examining how many rounds can be fired before malfunctions occur, and what types of failures are most common. They test the weapons under various environmental conditions: heat, cold, dust, moisture, to assess how the drum magazine mechanism performs when subjected to field conditions. They have soldiers of various sizes and strength levels attempt to fire the weapons and provide feedback on handling characteristics, weight distribution, and practical usability. The data from these tests accumulates, and the picture it paints is unfavorable. Feeding reliability proves inconsistent. Under ideal conditions on clean test ranges with fresh ammunition and carefully maintained weapons, the drum-fed carbines achieve acceptable reliability, perhaps 90 to 95%, meaning 1 or 2 malfunctions per drum. Under field conditions, with weapons subjected to dust, rough handling, and soldiers operating under stress, reliability degrades to 70 to 80%, 3 to 10 malfunctions per drum. These failure rates are unacceptable for combat weapons, where a malfunction can leave a soldier unable to return fire during a critical moment. Clearing malfunctions in drum-fed weapons is often more time-consuming than clearing simple box magazine feeding failures, because the jam may be occurring within the drum mechanism rather than at the chamber, requiring drum removal and potentially disassembly to clear. Soldier feedback from testing is predominantly negative. Test subjects report that the drum-equipped carbines are awkward, unbalanced, and tiring to carry and fire. The weight of the drum makes extended shooting painful as the weight pulls downward on the shooter's support hand and requires constant muscular effort to maintain proper sight alignment. The bulk interferes with natural weapon handling and makes rapid target transitions difficult. Soldiers express preference for either standard carbines with box magazines, or, if high capacity is truly needed, for Thompson submachine guns that are at least designed from the start to work with drum magazines, rather than having them grafted on. Cost analysis reveals that producing 50-round drum magazines for the .30 carbine would be expensive. Each drum requires precision manufacturing of multiple components, skilled assembly labor, and quality control testing. The Thompson drums already in production are among the most expensive magazine designs in American inventory. Creating a new drum design for a different cartridge would require tooling, development costs, and manufacturing capacity that could alternatively be used to produce other critically needed items. In a wartime economy where every dollar and every manufacturing hour must be justified against competing priorities, spending resources on drum magazines for M1 carbines competes with production of ammunition, more carbines, magazines for existing weapons, and countless other needs. The logistics implications add another layer of complexity. Drum magazines are large, heavy items that require specialized packing and shipping. A crate that can hold dozens of box magazines can hold only a handful of drum magazines. Warehouse space, transportation capacity, and forward distribution all become more complicated when dealing with bulky drum magazines versus compact box magazines. Units equipped with drum-fed weapons would require different supply procedures, different storage methods, and different handling protocols than units with standard weapons, all adding complexity to logistics systems already strained by global warfare. By late 1942 or early 1943, the experimental program exploring drum magazines for the M1 Carbine is effectively terminated. The prototypes have been built and tested. The data has been gathered and analyzed. The conclusion is clear. The disadvantages outweigh the advantages by a substantial margin. The drum-fed M1 Carbine works in the sense that functional prototypes can be built and fired, but it does not work well enough to justify production. Resources are redirected toward developments that show more promise: the selective-fire M2 Carbine, capable of full automatic fire, the 30-round box magazine that will become standard for the M2 variant, improved ammunition types, and refinements to the basic M1 Carbine design that improve reliability and durability without fundamentally changing the weapon's character. The experimental 50-round drum magazine for the M1 Carbine are placed in storage, used as training aids, or in some cases destroyed when their experimental value has been exhausted. A few may survive in museum collections or as rare curiosities in the hands of serious collectors, but they are extraordinarily uncommon because so few were ever built. Most soldiers who serve with M1 carbines during World War II never hear of the drum magazine experiments and would likely find the concept strange if it were described to them. The standard 15-round magazine, and later the 30-round magazine, proves entirely adequate for the carbine's actual tactical employment. The drum magazine's additional capacity is a solution to a problem that does not exist in practice. The story of the experimental 50-round drum magazine for the M1 Carbine illustrates several important principles about weapons development. First, it demonstrates the difference between theoretical capability and practical utility. In theory, more ammunition capacity is always better. Who would not prefer 50 rounds to 15? But in practice, capacity increases that come with substantial costs in weight, bulk, reliability, and complexity may not be worth accepting. The drum-fed carbine has greater capacity than the standard carbine, but it is also heavier, more awkward, less reliable, and more expensive. For most tactical situations, the standard carbine's capacity is sufficient, and for those rare situations where more capacity is genuinely needed, better solutions exist. Second, the story reveals the importance of designing weapons as integrated systems rather than attempting to combine components from different weapons designed for different purposes. The Thompson drum magazine was designed specifically for the Thompson submachine gun and the .45 ACP cartridge. It works adequately in that application, though even there it has limitations that lead to its gradual phase-out in favor of stick magazines. Attempting to adapt the drum concept to a completely different weapon firing a completely different cartridge requires essentially creating a new magazine from scratch. The resulting magazine may superficially resemble a Thompson drum, but internally it is different, and the weapon it attaches to was never designed to accommodate it. The system-level problems that emerged, weight distribution, handling difficulties, reliability issues, are predictable consequences of trying to force incompatible components to work together. Third, the experimental drum-fed M1 carbine demonstrates the value of the testing and evaluation process in identifying impractical developments before they consume significant resources in production. The program proceeded through appropriate stages: concept development, prototype construction, testing under controlled conditions, testing under field conditions, soldier feedback, cost analysis, and comparative evaluation against alternative approaches. At each stage, data was gathered objectively and analyzed honestly. When the accumulated data indicated the concept was not viable, the program was terminated rather than continuing for reasons of pride, institutional momentum, or political considerations. This is how weapons development should function: exploring ideas systematically, gathering data rigorously, and making decisions based on evidence rather than assumptions. The contrast between the experimental drum-fed M1 Carbine and the developments that actually succeeded is instructive. The M2 Carbine, with selective fire capability and 30-round box magazines, addressed real tactical requirements identified through combat experience. Soldiers reported that the M1 Carbine sometimes needed full automatic capability for close-quarters combat, and that 15 rounds were sometimes insufficient. The M2 with 30-round magazines provided these capabilities without the weight, bulk, and reliability compromises that drum magazines would have imposed. The 30-round box magazine added some weight and length compared to the 15-round magazine, but these increases were modest and acceptable. The magazine design was a straightforward extension of the proven 15-round magazine design, meaning reliability remained good. This development succeeded because it addressed genuine needs with practical solutions. Modern firearms enthusiasts sometimes encounter references to drum-fed M1 carbines in obscure ordnance documents, or as brief mentions in comprehensive histories of the M1 carbine's development. These references are usually fragmentary because the program was relatively minor in scope and short in duration. Reconstructing the complete history requires piecing together scattered archival material, photographs of prototype weapons, and occasionally oral histories from engineers or ordnance personnel who worked on the program. The resulting picture is one of an interesting engineering exercise that confirmed what practical considerations suggested from the start: that drum magazines and lightweight carbines are fundamentally incompatible, except in the most theoretical sense. Some modern manufacturers have created aftermarket drum magazines for various firearms, including derivatives of the M1 carbine, usually chambered for different cartridges or designed for civilian variants. These modern drums benefit from materials and manufacturing techniques unavailable in the 1940s, yet they still typically suffer from the same fundamental problems that plagued the original experiments: weight, bulk, and reliability issues that make them novelties rather than serious practical equipment. The persistence of these problems across decades and across improvements in technology and materials suggests that they are inherent to drum magazine designs for carbine-sized weapons, rather than simply artifacts of 1940s manufacturing limitations. The M1 carbine itself went on to become one of the most produced American firearms in history, with over 6 million manufactured during World War II and the Korean War. The weapon served effectively in its intended role throughout both conflicts and continued in service with various military and police forces for decades afterward. The standard 15-round magazine, and later the 30-round magazine, provided sufficient capacity for the weapon's actual tactical employment.